Okay, so we're continuing to solve systems of equations. So what does that mean, that we have a system of equations?
Two equations.
There's at least two equations, there's at least two variables. So the first day we solved graphically. If you've done your graphing graphically, you could send that down. Some people got those back with corrections to make because you have to get like half of them right. So I put some notes on papers like fix 1, fix 2, fix 3, whatever you needed to fix. If you gave that to me yesterday and you didn't get it back, that means you're good. But if you graphed some graphs, send them on down. What we did yesterday was we learned how to do a thing called the substitution method to solve. So 21 to 28, we did that. What's the first step of the substitution method? How does that start? Make one of the variables be alone. Number 21, 22, 23, 24, they kind of did you a favor. How did they do you a favor on 21, 2, 3, 4 already? They already got one of the variables alone for you. So 21, 2, 3, 4, the variable's already alone. The other ones you'll have to work on that. And then what you do, it's called the substitution method because you substitute that one problem into the other part and you go at it. So 21 to 28 was doing that method. I told you there'd be one with fractions, or you could have gone decimals. Which is the one who turned out fractions or decimals? Which number? 24. So 24, you're going to get two fractions or two decimals that involve fifths in some way. If you need some help, I'd be happy to do one of those. Just to remind you, tonight's homework, we'll do some word problems today. You're going to have to be able to solve these using the methods from this homework. But 21 to 28, did anybody get stuck on anything? Do you need any guidance? Quick, just what you're shooting for here. I guess you don't really need the answers from me. Why don't you need the answers from me to know if you're right?
You can plug them in. You
can plug them in to check. But for 22, we're hoping for 2, negative 3. 24, we're hoping for some stuff in the fifths. 26 is 2, negative 7. 28 is 4, negative 1. But again, I'd be looking for enough work that I can see what you're doing. The answers are not what I'm chasing for homework credit. I'm chasing a big page full of math writing. Last call, 21 to 8. Nobody needs guidance. Okay, 29, for a while we did a thing called the addition method. The addition method is going to be the better method to understand long term, I think, for how we're going to build up this chapter. So if you got the addition method figured out, that's a big pro. The first 6 are ready for us to just add the equations together, and that's why it's called the addition method. How did they nicely set up the first 6? How were they kind to you?
They had two opposites.
They had a pair of opposites. The equations already had a pair of opposites, so just add them together, the opposites disappear, you solve, and on we go. 30, we'd be hoping for 2, 7. 32 is positive 10, positive 2, 10, 2. 34 is the one with the fraction. This only had one in this group of fractions. It's going to be a half and then negative 5. Does anybody need some guidance or some example on the board or something of anything from those 6 where you had the opposites? Okay, 35, I said I'm going to call this the multiplication addition method because starting on 35, you had to multiply to create some opposites before you could add them together. And I can do one of these if that'll help anybody. 36, we're hunting 4, 5. 38 is 1, 3. And 40 is 2, 3 is the answers that we're hoping to find. Does anybody need me to do anything to try to reteach a little bit of yesterday to help that homework page along from 21 to 40? Okay?
Should you do
34. Okay, so 34, the equations have the opposites with the y's. So if I add those up, I'd get a 12x to equal 6. Are you okay with the 12x to equal 6?
Yeah.
Okay, when you go to divide then, it's not going to be a 2, which is a common error people make. You're dividing by 12, which is bigger than 6. So 6 on top of 12 will reduce to an x of a half. Did you have a half?
Yeah.
Okay. Then you could put that half anywhere. If you put the half into the, let's go into the bottom row. If I put a, or do you see something on yours 3 minus 3y? Or do you see anything like a 3 plus a 3y?
No.
Okay, so if we plug in the half for an x, 6 times x is going to make 3. Are you with how I can get a 3 by putting in a half for an x?
Yeah.
Okay, so you could either work the top equation that 3 minus 3y is 18, or you could work the bottom row that 3 plus 3y equals negative 12. Do some opposites there to lead you to the y. Rewind something more. I could go to the board to some degree with some.
Y is negative 5.
Yeah, y will be negative 5. Yeah, so we get half for x, negative 5 for y. Yep. Okay.
Yep.
Anybody else want any guidance on the 21 to 40 homework? Anything where you got stuck on anything in the problem area? Okay, so if you have that, send that down. If you did that graphing catch up, send that down. I'm going to pop up a page to page 164, and I'm going to pull an example out of the book. So as I progress here to my left to do these word problems, the first word problem, I'm working from the very bottom of page 164. There's a problem that says, try this. Try this, number 1. So this is one of those problems. You're just going to have to read it a word at a time and translate word to math. So it says one number. So what do you want to do about that? X. They say is equals 4 times another number. 4 times y. So we need 2 different letters because they are talking about 2 different numbers. Anybody trouble from sentence 1? Okay, so one number is called x, one number is called y. They say their sum is 175. What do you want to do about their sum? X plus y. Not the 4y, but the sum of the original basic numbers. X plus y, x and y are our basic numbers. Their sum is equal 175. Question about that. Okay, it said that the sum, so add, the numbers, x and y were the names we just picked. You could have picked J and P and use your initials or something, whatever letters you want or find. Is always an equals 175. You okay on that? Good. Anybody rewind how we created that? Okay, so there's 3 ways we could solve this. The first way we learned, which you're never going to choose to do, is to solve by graphing. Okay, you might need up to 175 squares for this one. So I really don't think you're going to do 175 squares worth of graphing. You could, but I don't see that as practical. Then yesterday we did substitution, we did addition. Which method is this better set up to do? Is this better set up for us to do a substitution move or better set up to do an addition move? I'd say substitution, because the first set of substitution is to get one of the letters alone. And I was circling that yesterday once I did. This already has a letter alone, so I would do the substitution method. If you see more x, y stacks, maybe with opposites, with all the letters there, then maybe that's an addition method better problem. But substitution works, get the one letter alone, and then where do you put it? In for the x in the other one. Since x equals this, we'll take this and put it into the other level for where x sits. So x gets replaced by 4y because this tells us that's fair. Still plus a y, still equals a 175. And now you're out of algebra 2, you're back in algebra 1, or 3L, or you're back a ways. This is now old business. So what's our move here? Put those together, get 5y equals 175. Divide, we get a 35. And if the y is 35, somehow we can get the x. Where's the best place to get the x to finish this thing?
35 times 4.
Go to 35 times 4. Go to that circle area. Once we know the y is 35, 35 times 4 gets us the x. That would be 140. That's the answer. Before I'd happily move on, I'd just think through and make sure we did what the problem originally said. It said that the sum should be 175, which it is. It says the one number should be 4 times bigger than the other one, which it is. And then I would say confidently, slide up to the next question. When you go to take on homework tonight, will be 2 days on 167. The first 4 are like this, where they're going to just give you a paragraph. You just patiently take one word at a time and turn it into one bit of math at a time. But 1 to 4 should lay out like this. Whether they all do the substitution method or whether they maybe sneak in some addition methods, that I can't speak to. I would guess they'll mix and match that. Anything about type 1 before we move up? Great. So slide up a page or 2. At the very top of page 166, there's a problem that says try this number 2. Okay, so Algebra 1, you still might have some bad memories of mixture problems and tables. I don't know if that's like a curse from your past. These are going to be actually a little easier to do, I think, than those that you did. It was sort of hard sometimes to do those word problem, mixture problem, table problems, because you were usually hunting like 2 things. There were 2 variables, but you didn't have the tools from this chapter. So it was like a little bit rough sometimes doing some of those. It's going to have a similar structure, but I think it's going to flow easier. So when we go to do the homework, the 167, 5, 6, 7, 8 are going to be like this. So I would suggest make yourself a table. There's some sort of type A thing that's going to get mixed with some sort of type B thing that's going to get mixed. It's going to make a total. There's going to be some amount of that stuff. Then there's going to be a percentage we're keeping track of. This particular one, after every percentage sign, it says weed killer. So what we're trying to keep track of is the percentage of weed killer, and therefore we're trying to keep up with the amount of weed killer. But I would just skim the sentence, see what you're keeping track of, set up a table, an amount, a percentage of something, an amount of something. I think Algebra 1, that was like usually acids or alcohols or sometimes sugars or other things like that. But there's always some sort of a descriptor. Level A, level B, and a total. So here we go. Gardner has 2 kinds of weed killer and water. There's one that's 5% weed killer. So let me gently go 1, 2, 3, 4, 5, 6, 7, 8, 9 for conversation purposes. In which box should the 5% weed killer go? 2. Box 2, it's the first type of weed killer, we're going to go with 5 there. There's another thing that's 15% weed killer. So what box is my 15 going to go? That is box 5 for 15% weed killer. Then we're trying to get, the Gardner needs 100 liters that's 12% weed killer. And we're going to mix these up. Anybody thought on the 100 or the 12?
12 is 8.
12 is going to go in box 8 because that is our other percentage. I agree, that's our total percentage of weed killer we're hoping for. Box 7 is where the 100 goes. So there's going to be 2 variables because we're in 2 variable chapter. So there's got to be 2 mysteries. They ask how much of each solution they should use. So which boxes are the how much, the variable boxes, what are we hunting? 1 and 4. So call this one like X or A, call this one Y or B or something, and then these we're going to have to work out a little bit more. But generally from each story there's going to be 3 or 4 numbers you'll know. There's for sure going to be 2 variables because that's what the chapter's about. Questions about how I transition from paragraph to table? Okay, somebody might have had a question about the percentages. What question might someone have about the percentages? something that we historically have done.
So you're not to make them a
Make them decimals. Okay, so if you want to make the percentage decimals, you can. If you, in this problem, want to skip it, you can, but you can't always skip making those decimals. So if you want to play it safe, make these all decimals every time, and you'll always be fine. When you're allowed to skip that is if these all would be made decimals. Eventually we could move them all over anyway. If every box is filled with a number, then you don't necessarily have to worry about making these decimals. So I'm not going to make them decimals, I don't feel like it. Does anybody remember how you worked across the table every time in the past, and you still will in the present and future?
You multiply.
You multiply across. So percentages always multiply anyway, we've talked about that. It's hard to make a percentage sentence without the word of, and of means to multiply. So 5% of this stuff is weed killer. This is a multiply world. So this is 5x. So we've got some weed killer there. Multiply across, there's 15y. There's some more weed killer there. If you multiply this, there's 1,200 total weed killer amounts. So some weed killer from this, some weed killer from that. Grand total is 1,200. This is going to be an equation. This is going to be an equation. Can somebody make up an equation? What do you think? How would those quantities interrelate? X plus y equaled 100 from the first group.
And then 5x plus 15y equals
5x plus 15y equals 1,200 from the last group. I agree. So that's what makes today new. The table helped us get to the system. We got a system. Now we're good. Question about that. Okay. Could we do substitution? Sure. You could do graphing too if you're willing to go 100 squares worth. But I think this one to me feels more ready to do the addition method. I prefer the addition method. We're going to use the addition method more. I think the addition method is faster. To do the addition method, we need to create some opposites. So if we want to create an opposite here, what number would we prefer? -5. If we wanted to create an opposite here, -15. Pick one, doesn't matter. I'm going to say -5 is going to multiply here, which means -5 is going to multiply there, which means -5 is going to multiply there. I'm going to create my opposites by multiplying all the way through, and now I've got my opposites set up. Question about that move to create opposites? Now what? Once we've got our opposites for this method, add them up. Hence the name addition method. So if we add these up, x's are gone. Y total, 10. Number total, 700. So the y is going to be 70 is true. And then back to this, originally we knew we had 100 total amount of stuff, so if the x is 70, the y's got to be the third. Now think this through for a minute. 130 does make 70, that makes sense to me. We didn't average equal amounts of this together. If there were equal amounts of 5 and 15, what would it have worked out to be total? If I had the same amount of 5 as I had of 15. 10. Why 10? It's the average. If I had equal amounts of 5 and 15, I'd have hit 10, because 10 is the average of 5 and 15. Since I got a higher number than 10, since I got 12, that means that there's more of the 15, because that was the higher percentage. So for me to get more of the 15 than the 5 by a little bit makes sense. For these, I'd rather get a descriptor of who goes with who, not just x's and y's, because did the original problem mention x's or y's? No. So the original thing, this was identified as being 5% stuff. So maybe do an answer like 30 of the 5% stuff and 70 of the 15% stuff. Then we have a descriptor to go with the amount. it wouldn't be helpful if you were a human in your garage for somebody to say, yeah, grab 5 of one and 15 of the other. Well, or grab 70 of one and 30 of the other, sorry, because you're like, well, which is which? Over here, we didn't need descriptors, because that was just numbers. It didn't have any descriptions of the numbers, it just said, hey, here's some numbers. So we live with numbers. Over here, there were descriptors. Question about the 164? Okay, then there's not an example like the 9, 10, 11, 12, although the 9, 10, 11, 12 is almost like this, so I'm just going to get you started on 9. So if you want to just flip another page or two, we're up to 9. They're doing investment problems. It's the same investment problems we did in chapter 2, but I don't think anyone liked it. Okay, the one question that turned out like $11,499.99. Remember that one? Like, people didn't like that one. So here's a different way to do the same problem, and I think this will be easier to do this way. So if you're like, oh no, is this that problem? Yeah, but we've got a better way, I think, to do that now. So 9, same kind of thing as what we just did. It said there's 2 investments. The money you have is going to total $8,800. In a year, they're going to get you $1,326 in interest. Some of the money got invested at 14%. Some of the money got invested at 16%, and that's crazy. I would sign up for 14% interest in a heartbeat. That doesn't happen. They want to find the amount we invested at each rate. So this time we're keeping track of a percentage of interest, not weed killer. There's an amount of interest instead of an amount of weed killer. But otherwise, this largely goes the same. Do you know how much money you have to put into this?
No.
No. So that's X. That's almost always, this top left corner square is almost always going to be X in our tic-tac-toe game. Do we know how much money went in the other investment? No. So that's almost always going to be Y. Total, we do know a total amount of money. What was our total amount of money we had to take to our investor? $8,800. Percentage, investment 1 was 14, investment 2, 16. Do we know the total?
No.
No. So we can't do the thing this time where we just act like the percentage decimal issue doesn't matter. I'm going to need to make this 0.14. I'm going to need to make this 0.16 because I don't have that same sort of consistency here of being able to deal with all of those numbers and have them all moved over. I only can move over some of them right now, so I can't do that. The world of math works. If you do something to somebody, you've got to do it to everybody. If you can't do it to everybody, don't do it. So multiply across, as always, this would be 0.14x, this would be 0.16 y. And unlike last time, we can't multiply across to make this number, but we don't need to. Why? We know it. What is it? We know that this is 1326. That was given to us. So there's no multiplying across because we were short a number. And I don't mean x like the variable, I mean x like that box does not have a thing in it. Question about creation of table. Then it should flow like the other one. What's the 1 equation? $8,800. The other equation?
Is it
0.14x plus 0.16
Y.
y.
13.
Question about that. I don't really like the decimals. I didn't really want to have the decimals before, but I was stuck because I just had to. I can fix that now. How could I fix the decimals now?
Move everything over.
Move everything over 2 spaces. So I can go regular 14, regular 16,
Double zero.
double zero that one. Question about that. This would be a silly graph, you would need 8,800 squares. Maybe. I mean, you could do it other ways, but you need a lot of squares. Could you do substitution?
Yeah.
Yeah, you could get this x alone without a lot of trouble. You could get that y alone without a lot of trouble. If you like the substitution method better, if you had better success last night on the first half of the homework, then do the substitution method. I prefer the addition method, and I'm going to keep pushing that to your direction. To do the addition method, we need to create some opposites. So I could either create a number there, which would be
Negative 14.
-14, or I could create a number there.
Negative 16.
Okay, it doesn't matter. I'm going to go always the smaller number. So I'd go negative 14x. I'd go negative 14y, and then I'm going to leave that to you. You know, you're going to get negative a big number. When you add those up,
X and Y.
2y.
2y, what will happen to the x's?
Cancel.
They'll eliminate. 2y will equal probably like a medium-sized number. Because since this is negative and this is positive, that's going to shrink some, okay? And that's going to be reasonable. And then you could just try to finish that from there. What you would want to do for the answer, though, is make sure you do these labels again. The 15%, 5% sort of labels from a minute ago. Whatever x is, you'd want to say that at the 14%. We're going to get y first. We'd want to say that amount for the 16%, but I'll leave that to you to take that one to the finish line. 9, 10, 11, 12, all should run about the same. Tomorrow I'll do another couple examples and we'll do the other half of this homework. Ultimately we'll end up on this page going to 26. But tonight's to 12 based on 3 problem types. Tomorrow, some trains tomorrow. Nothing to cheer up algebra life, a little bit like a train problem. So we got some train problems and some other stuff going on tomorrow. That's what I've got. Anybody question about how things happened or question about where this one needs to go from where I dropped you off? Anything I can do for people? Okay.